Here we have a fraction. When you see a fraction, perform the operation or operations that will get rid of the denominator. X is our denominator in this situation. So think multiply both sides by x to get rid of the denominator. When we do that, we have x times 24 over x is equal to x times 6. We have to do this to both sides. So the x's on the left will cancel and we'll be left with 24. On the right, we'll be left with 6x. So here, x is multiplied by 6. We're looking to isolate x. So we use the opposite operation to remove the 6 from the right side. So instead, we'll divide both sides by 6 because we're multiplying. So 24 divided by 6 is equal to 6x divided by 6. The 6's cancel, and we're left with 4 is equal to x. And we've solved it. Next, we need to check that x equals 4 is a solution for 24 divided by x is equal to 6. We'll set up a left side, right side. The left side was 24 divided by x. The right side was 6. If we substitute x equals 4 into the right side and carry out the division, we'll find that 24 divided by 4 is 6. And so the left side equals the right side. And therefore, x equals 4 is a solution. Solving equations. A value is separate from the variable if it is added or subtracted from the variable. For instance, 5 is separate from x in 5 plus x. 5 is separate from x in 5 minus x, and 1 is separate from x in x plus 1, and 1 is separate from negative x in negative x plus 1. Those are all separate variables. A value is attached to the variable if it is attached by multiplication or division to the variable. Here we have x divided by 3. The 3 is attached to the variable through division. Here we have 3x is equal to 153. The 3 is attached through multiplication. Here we have negative 2 times negative x is equal to 102. Here, the negative 2 is attached through multiplication. And here we have 51 divided by negative x. Here, 51 is attached through division. Many of the equations you will encounter will require you to isolate a variable that has attached and separate values. You should always deal with the separate values first. Eliminating the separate values first allows you to then go on to eliminate attached values. The only exception to this rule is when the separate values are in a fraction with the variable itself. We'll see this a little later on with example 8. Solving equations. Example 5. Solve for 3x minus 7 is equal to 23. We're going to go through this one and then give you an example on your own afterwards, just to show you how to deal with separate and attached values. Think we want to isolate x, so first we use the opposite operation to remove the 7, which is separate, on the left side. The opposite operation of subtraction is addition. So we'll add 7 to both sides and simplify. Once we've simplified, we'll have 3x is equal to 30. Now we have an attached value. It's 3 times x, so the operation is to divide. We have to use the opposite operation of multiplication, so we're dividing. We want to get x by itself, and we have to do this to both sides. So if we divide both sides by the attached value of 3, we'll have x is equal to 10, and we've solved. The last thing we have to do is a check. So we'll check that x equals 10 is a solution for 3x minus 7 is equal to 23. We'll do this via a left side, right side check. On the left side, we have 3x minus 7. On the right side, we have 23. We substitute in 10. Now we have to be careful with BEDMAS. We'll do the multiplication first and then the subtraction. So 3 times 10 is 30, and 30 minus 7 is 23. So the left side equals the right side, and x equals 10 is a solution to our problem. Now you try it. Example 6. Solve 4 over 7x minus 5 is equal to 20.